Where's my marker? Okay. So let's see. This might be reviewed to some of you. Maybe it's not to the others. So let's take a look. This is about solving absolute value equation. So we're going to start with equations first. We probably covered this in previous algebra classes, but it's good to kind of revisit it. And maybe there were some things that you still weren't really sure why they were. So
Is it 4.2 or are we going back?
we're going back because this is more like the fundamental algebra stuff. Yeah, we're gonna go back a little bit. Okay, so we're gonna start first with the absolute value. Okay. So there's different ways to think about it, but one of the formal definitions is so in math, we're gonna say the absolute value of a number is the distance it is to the number 0 on a number line. So if you're more of a visual person, it might help you out to kind of see what's happening here. So let's say I want to take the absolute value of -5, and then I also want to take the absolute value of 5. So through your math experience, what have you learned is the absolute value of -5? +5, and absolute value of +5? Also positive. So usually I hear students say, oh, it just turns it positive. Okay. Which essentially, yes, it's true. It is just turning it positive, but there's also like a more deeper visual explanation. Here's our number line. 1, 2, 3, 4. 5 is right here. 1, 2, 3, 4. -5 is here. And so the reason the absolute value of -5 equals +5 is because this 5 is referring to the distance. And so here, distance is a positive value. And so this guy here is -5 is 5 units away from 0. So it has a distance of 5 units, but so is +5. It's also 5 units away. So if you think about it like in terms of this, it's saying that when you have a negative, the reason it's equaling its positive is because it's that many units away. So we use this definition to now bring in an equation. Let's say I ask this question. If x represents a number now, so it's representing some number that we don't know, what do you think the equation absolute value of x equals 3 is asking you to find? And so to answer this question, I want you guys to go off of this definition. Okay, so just real quick with the usual folks that you check in with, just do a quick little check-in. What is in English? What is this equation asking you to answer with this definition? About it. Maybe write it down if you want. Up to you. And I think we usually do U4 here. What number U4 here?
To get Oh, yeah.
Yeah, but I'm 30 units away. Yeah, well, maybe let's get over there.
Yeah.
I don't know.
First of all, I feel weird, so.
For me, it's like.
I don't see.
All right, let's see. So when you guys are solving an equation, you're answering a question. Okay, you're solving for that, for X here. What did you guys think? How can I reword that equation in terms of a question using this definition? Someone, let me go on this side of the room. Anybody want to share out what you think it's asking you? Let me move to the middle side of the room. Any brave souls? Yeah.
That X, or that does you find what X is.
What has the distance from
Yeah.
0?
Okay. So X represents a number. Which one represents, which number is 3 units away from 0? Right? So if I look at a number line here, we look at a number line here, 0, 1, 2, 3. So 3 is 3 units away from 0, but what else is 3 units away from 0? Negative. So both of these values are 3 units away from 0. And so when you're being asked to solve this absolute value equation, here's where it gets tricky with the algebra, because there's not really any algebra that you do to get rid of the absolute value. There's nothing that, like, you can't divide by anything, you can't like square root anything. There's literally no algebra that needs to be done. Instead, what happens is this absolute value equation turns into 2 different equations. One for the scenario where you're on the left side of that number from 0, and one in the other scenario. Because there's two values that are the same distance away from 0. So what ends up happening is this absolute value equation turns into 2 different equations. One, you say, well, the case where X equals -3, or the case where X equals 3. And so usually the textbook will say, you get rid of the absolute value. You don't really do anything algebraically to do that. It's just conceptually, this will either equal 3 or it'll either equal the negative. Is that cool? Okay. So then we use this concept here, kind of in a simpler case, with a more complicated case. And that's where it can get a little confusing. Okay. So let me give you one. Let's call this example 1. Let me switch to blue. And let's call this example 2 and try to mimic that reasoning here that we did. So then we take it up a notch, we make those wings spicier, and now I have a more complicated absolute value equation that looks like this. And so what happens is when students see this equation, they want to get rid of the absolute value and then set it to -7 and then set it to +7. That's a common mistake that I see. Okay. You can't do this yet because you can only do this in the step where one side only has an absolute value expression. One side of the equation has to be only an absolute value expression. Yeah. Okay.
So the left side of the equation needs to be a negative, because it needs to have a negative distribution.
No, not yet. So what we need to do first is, you see how this +1 and this 2 are not inside the absolute value? I need to get rid of those values first. So what you need to do is isolate the absolute value expression first, and then this concept will kick in. Okay. So I can't split this up yet because I need one side to only have an absolute value. So I need to isolate the absolute value of X here. What would you guys do first?
Subtract 1.
Get that 1 out of there, subtract it. Then you end up with 2 times the absolute value of X equals 6. Does one side only have an absolute value expression?
No.
No. So what do we have to do? You gotta divide the 2 first. Cancels off. Now in the end, now I'm left with the absolute value equaling just a number. Now this concept will kick in. Okay, so first you got to do all the algebra to isolate the absolute value expression. Once you do that, there's no algebra. Now it just conceptually turns into whatever is inside the absolute value has to be 3 units away from 0. So either x will equal -3 or x will equal +3. And both of these are going to be your solutions. Okay. Plug in -3 here. What's the absolute value of -3? Turns into, what did you guys say? 3. But what is the 2 supposed to do with this here? It's supposed to multiply. So then it turns into times 3 like that. +1, that's 6 + 1, that's 7. So it checks off, right? Okay, let's make it a little bit more spicy, and then I'm gonna have you guys try one. Okay, so here's example 3. So now let's say we have solve the absolute value of 2x -3. So now I don't have just x inside the absolute value, I have a whole expression. +1 is equal to 6. So from here, can I split them up into 2 different cases? No, I need one side to only have an absolute value, right? So this +1 is not part of the absolute value. So what do? Subtract it off to both sides. So then we end up with the absolute value of 2x -3 is equal to 5. Okay. Now I have an absolute value equaling a number. Whatever this expression equals, when I take the absolute value of it, it has to be 5. So therefore, it has to be either -5 or +5. So from here, that's where it splits up into 2 different scenarios. Either 2x -3 is equal to -5, or the thing inside the absolute value is equal to +5. And then you solve each equation independently. So you add 3 to both sides. You get -5 + 3, is that -2? -2. Divide by 2. So then we get x equals -1. And then you solve the other equation. Get 2x equals 8. Divide the 2 off, and then you get 4. So most of the time for absolute value equations, there are 2 answers. Okay.
You said most of the time?
Most of the time, sometimes they both equal 0, which in that case is just the same thing. Yeah, because you can't have a -0 and a +0. Questions so far? I believe that on WebAssign, the solutions, they do it a little different, okay? So I apologize for that part. Meaning they, like their explanation is a little bit different from mine, okay? Here's the other thing that I want to really click with you guys. There's also another way of thinking about this equation in terms of functions, okay, in terms of functions. So let me grab, I'll start with this one here. Do it in black. So here's a graphical explanation of what's happening. Graphical explanation. Do you guys see how the left-hand side is this whole expression equaling a numerical value? So another way to think about what's happening is I'm going to create the left-hand side, and we're going to let we're gonna let it equal a function. So I'm literally gonna let the whole left-hand side equal that function. Okay? It has a graph. Oh, it's okay. It has a graph. Actually, let's go on Desmos so you guys can see it. Practice your transformations. Let's see. Hold on. Let me go to Desmos. A second. Go. Is it showing up? Oh, sure. I haven't even connected my computer. Oh, it's coming. Try to think for a little bit. I hope it works. Okay. So watch, if we let f of x equal, what was it, 2 absolute value of x plus 1? Okay. So here's a graph of it. It's a transformation of the absolute value of x function. We got shifted up 1 unit, a little bit of stretching happened. Now, what was the equation equal to? What do we want it to see it would be equal to? 7. So if I think about what's happening is I want to see what x values do I plug into this function so that it equals 7, or it'll output y equals 7. So let me put y equaling 7. When does y equal 7? So the graph is when I input the x value 3 or when I input the x value -3. And so those are the solutions that we got right here, -3 and +3. So there's also kind of like a graphical visual to what's happening here. For the other function, oops, I don't think I'm sharing my screen on Zoom. Hold on. For the other function, if I let the left-hand side equal that whole expression, so the absolute value of 2x minus 3, what is that, +1? But now I want to see when that function will equal 6, right? So I want to see what x value do I plug into this function so that it'll output y equals 6. And it looks to be at when x is 1, -1, or when x is +4. So here's like a visual way to check. So you answer these questions and you're like, oh, I don't want to use my attempts on WebAssign. How can I double check if those are the correct values? You set one side equal to the function and see when it equals a numerical value. Okay. Let's see here. Okay, let me give you guys one to try out. I'll leave this. What I'm gonna want you to do is solve it and then go on Desmos and then just check that it makes sense graphically as well. Let's try this out. So solve the absolute value of 3x plus 6 minus 1 equals 20. And check your solutions graphically. Right. Okay, try it out. Stop sharing the screen here. There you go. I'm gonna have you do the graphing thing a lot today, so just have it handy, either on a graphing calculator, your phone, the Desmos. So they do that. Let me do I'm gonna sketch this out real quick. Oops. Crossed at 7. If you guys could provide like a small sketch on your work there, just so I can kind of see that. I'm checking that real quick. And go Desmos or your graphing calculator. They're not required, but actually. So let's do one for you now. And then for the other one, let's say you want to see 107. Just in second, just put it literally to that 107. And then this is going to be complicated. This sketch will be fine. You can just kind of double check here. Yeah. Yep. All right, guys. Then, as you're working on those, I'll walk around. Here's some more extra problems I want you guys to try. Let's see. Yeah, we have fun. Okay, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6. 3, 4, 5. 1, 2, 3, 4, 5. So here, I'll show you. You got negative. Yep. Oh, come in. Give me a second.
So you are negative 9, but I don't have positive 9.
Oh, missing.
And then negative 9. subtract. Okay, there we go.
As you're doing that, let me post the solutions to that worksheet real quick. Week 5. Let's see, 5, here we go. Anyone worksheets? So you would let. I come back to the absolute value part. Like that whole thing. That would give you this graph. And you want to see, to solve this equation, you're trying to see what x will make this equal to 20. So as a function, you're thinking, what x can I plug in here so that the y will equal 20?
So when we put that in the decimals, the y's, I think we have to mess with it afterwards.
No, you would just then put when does y equal 20, which would give you this line right here.
Okay.
And then you see where they intersect. And then intersect when x equals 9 or x equals 5. That's when you'll get 20. Solutions. Okay. Save. So the solutions are on week 5 model. Yeah? For the graph part, guys, you guys can use your graphing calculator or Desmond, okay? To give you a quick picture of the graph. I will say on the worksheet, there are 2 equations that have no solutions. Oh, be careful.
We also subtract something in.
Right.
So just bring it out of the.
Real quick, just stop real fast, check with your group. Just double check you guys' work.
Yeah.
Do a quick little check. I am seeing different answers. Do a quick little check, please.
I do. Okay. I do see. Okay, that's what you see for the one. Negative one, negative one. Or whatever. Like, always have to have negative, yeah, that's why you negative. Because I got 5 with a solution. Well, that means it's one. Also getting a solution. Well, I don't know what. Like, what is the key area to that? Yeah.
So does that mean?
But I got the last. They come up. Absolutely. Positive. Never been. Yeah.
There's two equations that have no solutions. See if you guys can find them. Without looking at the solutions, of course. Take a look at the homework real quick.
Check it, you know, if we put it back into the equation, it's definitely forward.
Yeah, you can start with.
I don't know, maybe it's because of the process in, I have to add something to it, so can I just bring it down? And then subtract it from
So unlike these ones, you don't have to like move anything.
Yeah.
As this one, yeah, it's already isolated. So from there, you
Move it, X.
tell me what you mean.
I was thinking, it's kind of very, I don't know.
Gotcha. No, yeah, you can't do that yet. So what you need to do first is see once the absolute value expression equals a numerical value,
Yeah,
you have to then split it into two different equations.
so it would be X plus 15.
Equals negative
7
37
and it's positive.
and then positive 37,
Okay.
correct. All right, did you guys find the ones that have no solutions? 5 and 6, let's see why those have no solutions. Let's take a look. See, maybe you solved it, and you're like, wait, I got an answer though, what's up?
It's really obvious.
So you got absolute value of 5b plus 9 plus 16 equals 2. Okay, let's see. So I start solving it, minusing the 16 to both sides. So I'm left with the absolute value of 5b plus 9 is equal to, what is that, negative 14. And then what did you guys do from there?
We solve, but then it's like you can't solve for it. When 14 is positive, because you can't just make 14 negative.
Yeah. So, and the explanation is what we were saying in the beginning. When you take the absolute value of something, it's supposed to be the distance it is away from 0. So it's representing some kind of positive distance. Notice, if I plug in a number here, I'm gonna have to take the absolute value of it. So what will the left-hand side always have to be? It'll have to be a positive value. I can't take the absolute value of something and get a negative 14. Yeah. Let me just write down what I saw some folks doing. Okay, so some folks were saying, all right, I'm gonna split it up, and so that this is the negative of negative 14, which really just equals the positive of it. And then you were setting the other one to negative 14. And so then I saw people solve it. But let's just see what happens. What is that? 5? Let's say one of the answers is supposed to be 1. Let's plug in the 1. You plug in the 1, what's 5 times 1? Plus 9? It's 14. What's the absolute value of 14? 14, not negative 14, which is why it's not a solution. Okay, because no matter what I plug in here, it has to be a positive. So if you see this on the homework, and your absolute value expression ends up equaling a negative, right away, there's no solution. An absolute value cannot equal negative, so all of this work is irrelevant. It's incorrect. Okay, be careful. Okay, let's go on to inequalities. So it's okay if you're not done with the worksheet. It's just additional practice. I want to get to inequalities though. That's where it starts to get funky. Have we done any inequalities in class yet?
Yeah.
Oh, when we were comparing real numbers. That's right. Oh, perfect. Perfect. I know what I'm doing. It's okay. Good. Good. Okay. So. Shit, I went the wrong section. All right, let's take a look. So let's do section, the next one, which is 2.3, solving absolute value inequality this time. Let's go off of what we know so far. So since the absolute value of x means the distance x is from 0, come on, for inequalities, let's see what you guys think this will mean. The absolute value of x is less than 3. Versus the absolute value of x is greater than 3. Okay. So we're thinking of the absolute value of x as like how many units away it is from 0, right? Cool. Okay. Let's put a number line here to help you guys out. Here's 0. So in English, using this distance definition, what do you think the inequality is asking me to find here, this guy here?
Distance from 0 that's less than 3.
You want to find all the numbers whose distance from 0 is less than 3 units away. How many solutions do you think there are? Can you guys think of a number that's less than 3 units away from 0? 2, 1, 0, negative 1. Negative 3 is negative 3 less than 3 units?
No, it's not.
No, it's exactly 3 units, right? So negative 3 wouldn't work. Any other numbers that are not integers? 2.1, 2.2, 2.3, 2.4, all those numbers, right? So notice that for this scenario, here's 0, 1, 2, 3, 1, 2, negative 3. So any number, let's use a different color. Any number not including 3 or negative 3, but any number in between negative 3 and 3 will work here. Because those are all numbers that are less than 3 units away from 0. Is that cool? Okay. So, you know how, okay, I erased it. You know how we were splitting up the absolute value equation into 2 separate equations, but now they didn't have absolute values? Yeah. Similar thing will happen with this. Here, this inequality, you can think of it as saying, I want to find a number x that is less than 3 on the number line, but also greater than -3 on the number. Okay. So what happens algebraically is whenever you guys are left with an absolute value less than a number, it is then rewritten into a different type of inequality called a compound inequality, but no longer with absolute values. Okay? I got a little too excited. Let me move this one over here. Let's do this. 1, 2, 3. 1, 2, 3. Okay. Give me a number that would work for this other inequality. 4, -4, -5. So you want numbers that are more than 3 units away from 0, right? So that's going to be anything less than -3, but not including -3, or anything greater than +3, but not including. Those are all numbers that are more than 3 units away from 0. So how can I express these numbers with an inequality? These ones right here with this interval.
With the U.
The U will come in. X is going to be less than -3, or X is greater than 3. And so here's where it gets tricky. If the absolute value is greater than a number, it splits into 2 separate inequalities. One, where now the inequality switches and negates the number, because it's going to be less than the negative of it, or the same thing, greater than that number. Okay? And correct, you guys are right. You're going to have to use interval notation. Okay? Because there isn't just a finite number of solutions. There's like infinite. So you need an interval for that. So you're going to say the solution here, you would write it as there's no smallest x value, and then we go up to -3, parenthesis. Your fun union here. Do we include the 3?
No.
No, we do not, because there's no equal sign, so it's from 3 and on, like that. Yeah, this could be this. And then for this scenario, the solution that you would write is all the x values. What's the smallest x value that you approach? But not included, right? So it goes from -3. What's the biggest x value? 3. So your answers are going to be in interval notation for inequality. So let me just write the general rule, right? So we use this so that in general, when you have the absolute value of an expression less than or equal to some number, we're going to call it A. Now I'm getting all general here. This means that's like this scenario, that x is going to be in between what and what? Positive is between -A and A, correct. So it'll be between -A, greater than -A, but less than +A. So when you get an expression like this, you're going to then rewrite it like this. Okay. And then when you have the absolute value is greater than A, that's like this scenario, you want to be more than A units away from 0. So that means that it'll have to be less than the negative of it, or greater than its value. Oops, I forgot to put the equal signs, sorry. So then when you're left with a greater than inequality, you're going to convert it to 2 separate inequalities. So this is the general, this is what you're gonna do a lot in your homework. This is bad. Break time? Your eyes say yes. Let's do a break. So come back at 1:50. We'll resume. You guys are doing good. A is just some value. It's whatever number is there. Yeah. Yeah. Like right now, the A here is 3. Yeah. So it's more like a rule. It's more like a rule. Yeah. Usually rules will have variable instead of a value. It's just like a placeholder. All right, so let's see how you guys are going to solve these. Let's do some examples, and I'll have you guys try some. So let's say we have a weird absolute value like that. So we have the absolute value of x minus 3 is less than or equal to the number 2. Okay. So everything inside of the absolute value, think of it like this x here, the whole thing inside of it. Okay. And this a, think of it like the 2. So it's saying you want whatever is inside here to be less than 2 units away from 0. Right? So that will have to be what? Is it going to be in between -2 and 2, or is it going to be away from -2? Maybe in between. Right? In between. Maybe if you want underneath this picture, you guys can put here's -a, positive a, and you want to be in between. And for this picture, you can do the opposite. You want to be away from those values. So that's correct. So again, like with the equations, once your absolute value expression is isolated, there's no algebra that you can do to get rid of the absolute value. It just, you rewrite it into its other equivalent form, but with a compound inequality, so that we get x minus 3 is going to be in between, so it's going to have to be less than 2, but greater than equal to negative. Okay? Siri will do it for me. Later on, we'll have a chat GPT series. Okay? But there's a little bit more to do because we're trying to get x by itself. So what would you do to get x by itself if it was just this inequality? Add the thing, right? But here, the reason this is called a compound inequality is because you have multiple inequalities. So if I add the 3 here to get rid of the 3 and isolate x, see how you would have to also add 3 on this side? So I also have to do it to this side. I have to do it to both sides and the middle. So this will cancel. So now I end up with 1 less than x, and then less than or equal to 5. And so then that tells you the x values that would satisfy the inequality, but you have to write it in interval notation. Okay? So you want to be from 1 to 5, including 1 and 5, because it's equal. So what is the first thing I do to do my solution? Square bracket. Comma. That's right. Okay. Any number between that will satisfy the inequality. All right. There is again a graphical explanation on why this is also the answer. Okay. So I'm going to go back to what we were doing earlier with the graphical explanation. Well, let's see. We're going to let, again, f of x equal the absolute value part. Absolute value of f of x. Absolute value of x minus 3. We'll see where this 2 comes into play. And if you graph this guy here. Remember the absolute value function looks like that. This is a transformation. What is it doing to it?
Moving it right.
Moving it right by 3. Remember, this is the opposite, right? So it's going to move it to the right 3 units. So now the graph is going to look like this. Like that. Okay. But here you want to see when this function's values, when the y values are going to be less than or equal to 2. So if I put 2 here, here's 2. Okay. So this result here is telling me the x values from 1 to 5, right here and right here. That's when the y values will be less than 2. You guys see that? Right, if I chop off the top part of the graph, from here to here on the graph, those are the x values where the function will be less than 2. So that's kind of what's happening. Okay? That's why this here, from here to here is your solution. Versus if I flip the inequality to be greater than, then it's going to want us to look for when the graph is greater than 2. So I want to show you that example. Let's do one more and then I'll have you guys try one. Two. Let's say we need to solve. I'm gonna make it hella nasty now. -3 absolute value of x plus 1 plus 5 is less than -10. All right. So just like before, in order for you to use these rules, the absolute value of x, the absolute value expression has to be isolated. So I gotta get this absolute value expression all by itself. What do we do first? Subtract that 5 out of there to both sides. So I end up with -3 absolute value. What's that? -15, and then and switch the sign. Yes. So that key is really important. I got my red markers gonna work. It never works. Let's see. Sick. So at this step, you gotta be careful. Oh no, it's dying again. You gotta be careful. So you must flip the inequality whenever you what? Divide or multiply both sides by a negative. Okay. Whenever you divide or multiply by a negative. You forget to do that, you're going to get the wrong answer. So because we divided by -3, they cancel, but now we get absolute value of x, and I have to flip the inequality because you're negating both sides of the equation. Okay, and so that turns into greater than, what's that, 5? 5. And so notice that now that is kind of like this expression. Right, the absolute value is isolated and it has greater than 5. So do you want to be in between -5 and 5, or do you want to be away from -5 and 5? If you're going to be greater than. You want to be more than 5 units from 5, right? From 0. So you want to be away from those values. So I need x plus 1 to be what in terms of -5?
Less than.
You want it to be less than -5. Or you want x plus 1 to be greater than 5. So here you got to make sure you flip, you negate the number. -1 to both sides. You get x must be less than -6. Or -1 to both sides, x must be greater than 4. But you guys will have to write your answer in intervals. So let's see, let me do a visual here. So there's -6, there's +4. I want x to be less than 6, -6, but greater than 4. So how do I start writing my interval? Negative infinity with a parenthesis. -6. Do I equal it? No equals, so parenthesis. Then union 4 to infinity. All those x values will satisfy inequality. Rohan, yeah.
So I know one of the properties.
At this step here. So this flipping has nothing to do with this step. This flipped because you divided by negative. This flipped because of the equivalence between this inequality and this compound inequality. For x to be more than a units away from 0, it must be less than negative. And so here, I want the x plus 1 to be greater than 5 in terms of distance. That means I want it to be more than 5 units away from 0. In order for that to happen, x plus 1 has to be less than -5. Exactly. Yeah. Yeah, exactly. Yeah, good point. Okay, let me have you guys try one. I'm gonna have you try 3. Let's see, I'll leave this here. I am gonna have to erase this. Be careful with the negatives. All right. Let's see. You guys practice these guys. So solve the following. Okay, number 1 is the absolute value of 1 minus 2x is less than 7. Number 2 is the absolute value of x plus 1 greater than or equal to 3. And then the third one is 9 minus 2 times the absolute value of x minus 3 is greater than 1, greater than or equal to 1. You guys try those with your group. Let me see the red on here. Yeah, you can. Let's. So refer to your notes to know how to write it into a compound inequality between the values or away from the values.
questions. If I had to end up consider, right? That the one and one X together, the rest have to do subtract X rather than.
So here you don't want to have the two because you see how the two is actually multiplying
But
by X.
that's so the
Oh,
one.
So you want to get rid of the one first.
Okay.
Luna? Be careful with the negatives. All right, let's do a quick check with your group. You guys agree? Make sure your answers are in suitable notation. As well.
It's one. I know that. It's not sweet. It's not one. It's
Negative four. Yeah, I know. Negative four is best. Yeah. Second one, yeah. For the first one, when you still put out the. Okay, so just speak the right away. Yeah, I don't. Yeah, because I don't. But yeah. No, I mean, yeah. Well, I see why is it almost. I mean, all of again, it's all. Oh. Well, like one side is, I have to see where. Yeah, but I might. No, I think this is definitely, no, I didn't. I didn't for it, and after that, I would like it, negative by negative.
The graph that you line.
So I can get. No.
You can if you want. You don't have to know, but I think it might help for you to switch it when you're waiting in the school.
How easy. Now this is. No, it's not, this one, it's kind of supported. You have to put the sign. Yeah, yeah, the sign and finish and then make it negative. Right. What would you know? Okay. Yeah, you're right.
With the final one, I did.
Yeah.
Did you get -1 as well? Oh, okay. Yeah, yeah.
It's a -173. Yeah, but a real. We really did that. I basically say that. Oh, yeah, yeah. Now. Yeah, now. Yeah, but that one's. It's because it's pretty white.
Which one?
Yeah.
All right, guys, let's see. Let's try these out. There are several questions. The negatives are bugging some of you guys. So let's take a look. We got 1 minus 2x less than 7. Let's see here. So what did you guys, is it between -7 and 7 or way?
It's low.
If it's less than, you want it to be less than 7 units away, right? So it's gonna be in between. So I'm gonna write what's inside my absolute value in between, so less than 7, but greater than -7. Okay? But yeah, you guys are right. You gotta be careful here. So what do I attack first to isolate X? Do I attack the 2 or the 1? That's one thing I'm seeing some people. So you don't, yeah, you want to first get rid of the 1 because the 2 is being multiplied with the X. So to get rid of the 1, what do? Subtract 1 on all sides of the inequality. So then this becomes -8. This sucker's gone. Don't forget that negative. Bring it down. 6. And then, so what's going to happen? All the signs flip. They all flip. So this becomes +4. And this flips. -2 cancel. This flips. Is that -3?
Yeah.
And I did see some people write this. Like that. Why is that incorrect?
-3 goes first.
It has to be in increasing order. It has to be in increasing order. So if you're having a hard time knowing what to put first, you can always draw it. Here's -3, here's a 4. X is greater than -3 and less than 4, so it actually doesn't go all the way, it gets stuck like that. That way you visually see, oh, it's from -3 and 4, but not including.
He has a question.
Yes,
I wrote it as like -3 is greater than X and like I essentially put like that.
oh, like instead of writing it in the middle like this,
No, I wrote it like that, but for the 4 is, I wrote it in reverse order where it's like -3 is greater than X. Greater than X and yes.
hold on, like that,
No, the,
or like that,
yeah, is that one? Or and then point and then try your forward.
like that,
Yeah, is that one?
correct, yeah.
Okay.
Mhm. You're just rewriting the same inequalities, but like in a different order. As long as X is greater than -3 and less than 4, it's fine. Yeah. We just do them separately. You could also do them separately. So you can also write it as, you can write it as X is, what is that, less than 4? And X is greater than -3. Correct. Whatever your style is that doesn't confuse you. Okay, so you can do it this way, or that. Okay, let's do the third one. That's the other one that was bugging you guys. Let's see, 9 minus 2 absolute value of X minus 3 is greater than or equal to 1. Okay, what do we attack first? Yeah, you're trying to get the absolute value expression isolated, so minus the 9. Do I flip the inequality? No, I'm not dividing or multiplying, I'm just subtracting. These go away. That's what, -8?
Yeah.
And then you divide by negative, so you have to flip the inequality, correct? These cancel. So I end up with X minus 3, gotta be careful here, flip it. +4. Okay, and then, am I in between -4 and 4 or away? You're in between, you're less than. So X minus 3 has to be less than or equal to 4 or greater than or equal to -. And then, yeah, gotta add 3 to both sides or all 3 sides. So we end up with -1, and then X is greater than or equal to -1 or less than or equal to 7. Or however you want to rearrange it, as long as it's keeping this, the essence of the relationship with X and these numbers. So what's that? Is it goes all the way to -1 and all the way to 7. So it's in between, but it includes it this time. So your answer is going to be from -1 to 7. Cool.
And the answer for number 2.
And then the answer, here, let's just do it real quick. But before I go on here though, hold on. Any questions on this one?
Basically, when it's like that, 2 numbers on the endpoint, it's the 2 endpoints are the answer.
At the end of it, yes,
Yeah.
but you have to isolate the X first.
Yeah, but like those 2 numbers didn't go either. endpoint.
Will be the bounds.
And then for the other ones, since X is in the middle. It's the same thing. Yeah, it is.
It's similar, but the thing that's confusing is that this number on the left is actually greater than this number.
That's just why you put it in this.
So that's what B was suggesting. She's like, I just rewrote it so that it was an increasing order, which is fine
So
too.
you can't write the final answer as a -3 comma 4.
This is how you write the answer, yes.
Okay, but you're just having it like that because what she said is.
Correct. Correct, sure. Yeah, like if you stop here and then your interval says 4 comma -3, that's incorrect. Because that interval is not an increasing number. You should have the smaller number on the left, the bigger number on the right.
You have half points for that or it's 4 long?
I mean, you will get some, you guys saw my way I grade partially, you'd get some points off, little point, -1, -1.5 or something. For the second one, let's see, x is greater than 3, so is it in between or away? Away. So we're gonna have x plus 1 be less than or equal to -3, or x plus 1 be greater than or equal to 3. So you -1 to both sides, and then you'll get, let me do that real quick. What's that, -4? Or greater than or equal to 2. So in this case, again, if it helps you graph on the number line, here's -4, here's 2. X is going to be equal to 4 or to the left or to the right? To the left, because it's less and then greater than 2. So in this case, if your intervals don't overlap, then you need a union symbol. Okay? So this one goes from -infinity to -4 included. Yep. And union include the 2 to infinity. So this part of the homework will be just as nasty, maybe some fractions will show up. Okay, I need you to practice that. Okay. Okay, that's it for these sections. So let's take a 5-minute breather while I erase this part here and prep for the next part. There's a little presentation-ish. So this little presentation is more for the, I created it because a lot of students say, I know how to study for my English class, I know how to study for my history class, but I just don't know how to study for my math. That's where it's kind of hard, or I just keep trying to do something and it's still not working. Something's not, I can't find a productive way or a successful way of doing that. So hopefully this helps. Let me just have the thing ready real fast. Okay. Can I erase this? Yeah. Actually, I'm just using this. I'll just. Okay, guys, so let's see. All right, so the secret to being successful in math at DVC, but outside of DVC as well, okay? So the three things I want to show you guys first is usually how a math course is structured. So what is it that the instructor is thinking of when they're structuring their class? How can I get help outside of class? And some of you guys are familiar with the Math and Engineering Student Center, but I wanted to just also highlight some other things that will help you with the stuff above. Whoops. Okay, so there is in education, there's this theory of how a person learns. And one theory is something called Bloom's taxonomy, which kind of layers the levels of how you're learning something. So when you're presented with a concept, there's a certain structure and hierarchy to the levels that you're going to reach to eventually become an expert at that concept. Okay, can you guys read that in the back? Yeah, okay. So the first one is called the remembering level. Now I'm going to go off of this, but then bring it back to math. So this applies for anything though, any class, any concept, even outside of school. Like if you're a fitness instructor and you're trying to learn a particular thing, or you're a dancer or whatever it is, okay? So first is, can the learner recall or just remember the information that they have? So in math, it's usually like formulas, definitions, very kind of
core in the beginning stages, and we have understanding. Can the learner explain the ideas or concepts? That's kind of what I'm trying to have you guys do with the problem sets, and you guys have to write things in your own words. Can the learner use the information in a new way? So now you're applying the concepts that you have been understanding. Can you then distinguish the different parts of what it is that you're learning? How are these different pieces kind of fitting together? Later on is about justifying. So usually, like in an English class, that's where an essay comes in, and you have to kind of explain or defend a particular view. And then the last one is the creating stage, which is, can the learner create a new product or point of view? Okay. So let's see how this has to do. These are usually what's called the verbs when creating a question, right? So these are things that we also talk about with our tutors. But I want to talk more about the math part of it. So usually in a math class, the instructor, they present a topic to you, and they're not going to present the topic and expect you to be right here right away. They have to build it up. Okay. So we start at the remembering stage. Can you recall facts, rules, or formulas? So what's the definition? What's the quadratic formula look like? What's the definition of a one-to-one function? What's the definition of a function? Just very basic. Do I just know what the definition is? Usually that's like the flashcard stuff. Okay. Then you get to the understanding. So do you understand a math technique or a method that you're covering? So if I look at an inequality and I see, sorry, I look at an absolute value and I see an equation versus an inequality, so can I explain to someone why the process is different for each of those? Okay. Then we get to the applying stage is, can you use different techniques or methods to a problem? So once you are able to kind of explain why you have to do this particular step, then that's where you guys then are given your problems where you have to apply those methods on your homework or on your problem set. Analyzing, can you break down a problem or a math concept? Can you change anything about it, still make it work? So here's when you guys are asking me questions like, what happens if blah, 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 right? That's kind of where this is coming in. Those are the things you want to do as well when you're studying those concepts. Evaluation or evaluating. Can you explain why a certain math concept or technique holds or it doesn't hold? Okay. So can you explain why this value is not in the domain of the function? Why is it not a solution? Things like that. And then the final stage is the creating stage. So can you draw a conclusion from a math work or result? Can you make a general rule? So I erased it, but the little rule that we had earlier for absolute value inequalities, those are general rules, right? We use some of the concepts we were doing to create a general rule that will hold for everything. And so in a math class, that's usually where this goes up. Now, this part is the hardest part to get to because you have to fully understand something to create it. And it's also kind of where word problems get hard because they require you to do a lot of these higher level things. Okay. So what I want you guys to do real quick with your groups is there's different things that happens in the math class. You've probably seen that here. There's in-class activities that we do. You guys have your own homework. There's exams, or maybe you have a project in another class. Some have small quizzes, weekly quizzes, things like that. So with your group, I want you guys to try to think, where does this activity, what levels of understanding do you feel it's trying to have you reach? Okay, so just do a quick check-in. Check in with your group.
Trying to understand. Also, like trying to remember. It's not applying. We saw. Applying or kind of. I don't know what exams of the project. They require you to be
Again, also. Yeah. I guess my kids have 1970 always. I'm just thinking of like this. Oh, yeah. The in-class activities.
They receive.
Maybe, okay. I don't see much of
Maybe it's- Because I'm not.
I feel like the way things are supposed to do with something like creating. I feel like. Like we went.
All right, guys, let's see.
I'm not.
No, that's fine.
Okay.
So let's see, small quiz. What were you guys saying? What do you think?
Analyzing.
Like somewhere around here? Okay. Applying as well? Okay. What about homework? Understanding, so that's a little bit lower than the quizzes. Okay. In-class activities, remembering, understanding. Okay, so also kind of a little bit lower level here, and then your exams and projects, evaluating. It's a little hard for an exam to do like the creating part. So that's usually where the projects would come in, right? That's not necessarily true when you get to higher level math, because with higher level math, you have to do something called a proof. You have to prove things. So and those exams are scary because they give you a certain problem or a statement, and then you have to prove it. You have to create the proof yourself. So it is very high level in terms of creation. You guys don't have to prove, so it's fine. But yeah, so you guys are saying a little bit of the higher levels for the exams, right? Okay, sweet. So let's see. Now try to be as honest as you can with yourself. It's okay if you don't want to share with your group, that's fine. But now I want you guys, when you're preparing for the exam, or let's say this first exam, and you guys walked in that day. So where would you say, in terms of the concepts that you were going to be tested on, what level do you feel you were at? Okay, when walking into the exam.
Yeah. I think on the last. You just read your.
Okay. So I do hear a lot of chuckling. So wherever you were at, just keep that in mind in terms of what you guys were discussing earlier. Exams usually tend to be kind of putting you around here. That way you kind of have, I guess, more of a systematic way of seeing like where you need to be at when you're trying to study for the exam. And so, yeah, so I'm just kind of summarizing a little bit what you guys said here. It kind of depends too on the quizzes. There are some harder quizzes, which are maybe weekly quizzes or like every 2 weeks, every 3 weeks. Canvas discussions are usually trying to put you guys to start thinking about these concepts at a higher level. Class lectures, easy homework problems. And so the issue is, because the math course, or usually a STEM course, has so much material that we have to cover, as much as an instructor tries, they're trying to do all these different activities to help you reach a higher level. We just don't have enough time in class, because then we have to move on to a next section or a new topic, okay? And so the famous question or the famous complaint is, what does my exam look like my homework? What the freak, man? Okay. And that has to do because of the structure of the question and the level of the question. So because, as you guys said, the homework is usually trying to put you, like, help you reach these areas here, but the exams are higher level questions. So that's why they look a little different. Okay. Oops. Oh, and so the issue, or I guess the thing that I've noticed is the students say, but I did all the homework problems and I did it like 3 times. And I still felt like I wasn't prepared for the exam. And that has to do because as much as you're doing those homework problems, you're still just only capping yourself at a particular level of understanding. Okay, so it requires more than just doing homework problems. It requires you to do other things that are going to help you reach these higher levels of understanding. Okay, unfortunately. Okay, and so to help you go outside of those higher levels, there are different things that you guys need to start learning how to utilize. You don't have to do all of them, but they are definitely things to help you reach higher levels of understanding. Tutoring, that can definitely help you as you go up. Even if you feel very confident with a concept, when you're in a tutoring session, tutors are trained to have you explain things back to them, or help you see steps that you kind of just did, and then you're like, I don't know why, I just know how to do it. That's the other common thing. I don't know why how it works, I just know I have to do it. Okay, that means that you're still not at this higher level of understanding. You want to be able to know why you're doing that step or why it's valid. Okay. Student office hours, they're not necessarily tutoring, they're a little bit different. Where you can ask, you know what, there's this concept, I'm still a little bit not sure about this lower level question. Can you help clarify it, right? So some math will build on itself, so it's hard for you to excel and get higher in the level if you still have a lot of holes in the lower levels of understanding. And that's where you want to utilize this. We get paid, instructors get paid to hold office hours. So you want to make sure you make, you're paying for the class. So what did I tell someone else about the class? You're going to buy a car, you're going to get a product. Are you just not going to ask any questions about the car you're buying? Hell no. You want to like, you don't want to ask as many questions to make your money's worth. That's the same thing with the content that I'm helping you guys learn. It's the product. Study groups is, in my opinion, one of the most important ones, because when you guys transfer to university, they go really fast, and they really rely on your self-discipline to cover a lot of the gaps on your own. Okay. They don't have a lot of time to go over examples, so it's very lecture heavy. Especially in a math class, it relies on you to read a textbook a lot. Believe it or not. Okay. Which is very confusing because you guys aren't really forced to read a lot of the textbook. Like there's a lot of videos, there's a lot of different instructional material outside there. So it helps to be in a study group because it forces you to be like, to help your classmates and explain certain concepts that you normally don't get to do. And then online resources, all the other good things that you guys do. So I had you guys do an interview tutor activity, just so that you can maybe see that they're just like you. And they're not all like these straight A students that just whizzed through math and didn't struggle at all. Okay. Usually we try to hire tutors that did struggle a little bit. They just learned how to succeed from that struggle. So they can share that and model that with you guys. We usually try to hire someone that's not just good at the content, but also has the social skills and is approachable to someone. Especially with math, because there's so much anxiety and fear around the subject. Problem sets, homework, that's what they're there to help you out. They're not homework doers, okay? They're there to help you reach those higher levels or any holes that you have in your learning. So, the tutor won't be that good of a tutor if you give them 20 minutes to learn whatever's on your test. So the student will come, I have a test and I'm so lost. When is your test? In 20 minutes. They're not gonna, it's just not gonna happen. Because they're gonna be forced to start from the bottom and help you reach those levels of understanding. That takes more than 20 minutes for a test, right? Like if you're really at the very bottom of those concepts. And then because of COVID, we switched to online. So now we have a whole online structure for tutors. For student office hours, I think it took me maybe like towards the end of my community college experience to understand how to utilize an office hours. So as I said, this is a specific time when the instructor is paid to be available just for students. So it's not that you're interrupting their work. They're literally there during that time frame just to help students, okay? Ask specific questions about your grade, an assignment, college advice. An instructor has been in college, has been through the academic experience. So it's some students kind of just want to share some advice, clarifying assignments. Somebody in another class didn't get points only because they misunderstood the question and they didn't complete it correctly, but then they came and I was like, oh, no, this is what I was trying to say. Clarified it and went ahead and changed it because they were not sure what to do. The other big one is recommendation letters, okay? Who's maybe thinking of applying for future letters of rec? Who's gonna transfer? Okay, then you need a letter of rec. Okay, scholarships, you're gonna need a letter of rec. It's very hard for an instructor to write you a strong letter of recommendation if they don't really know much about you as a student or just as a person. Okay, so this is a great way to build relationships. Also, just try to give them at least 2 weeks notice before the letters due. Otherwise, it can't be as strong of a letter. At least for me, I'm not a strong writer. It takes me a while. But yes, building a relationship is very key. Maybe you don't even think you're going to need a letter of rec from that instructor, but then down the line, you end up needing one from a specific subject, for example. So you never know. This is just a tip from me because that's what I did. I went with a friend because I was very nervous to go to my office hours. So I was like, come with me and just like, we'll be support buddies. And as I said, you're paying money for the class, so you got to make your money through. Okay. Questions so far? I have a fun, I'll share a story. So when I was at Cal, I took a summer course, which is, I guess, one of the harder math classes to take as a math major. But I needed to you guys have your academic plan and I need to get out by this time. So I was like, it was called real analysis. And it was really, really challenging for me. And it was a summer class, so it went twice as fast. And it was the instructor's first time teaching it, which is not good in terms of it's the first time teaching it, but they're researchers. So they just go hardcore with the proof stuff. So look, okay. So it was summer, tutoring hours conflicted with my class. So I couldn't find a tutor outside of class. So I relied on office hours. Went to office hours, knocked on his door. I was there literally when it started. And he was leaving. I was like, oh, I thought you had office hours. He was like, oh, I have an important meeting. I have to cancel it today. So I was upset because I was like, well, one, you didn't say anything. I didn't announce it. So then I was stressed out. And then I went to the university gym to like, just like what am I gonna do with this class? And there they have a racquetball court. And there was that fool playing racquetball with his friends. So I was pissed. Anyway, I just wanted to share that story. Not all of them were like that. It was just that scenario. Another student had a great experience with that stuff. Okay, study groups. So getting help from your classmates. That's why I'm so keen with you guys sharing each other's work, because sometimes the instructor can be very technical when they explain something, versus your classmate says it in a completely different way. You're like, oh, that's what they were trying to say. Okay, thank you. I didn't know that. By helping your own classmates and having to explain certain concepts, it's going to force you to get higher and higher in your level of understanding. That being said, one of the hard parts of a group study groups is finding a good group or finding classmates that fit with your style of learning. I know that when I was trying to find study groups, sometimes I was like, oh God, I just feel stupid in the study group. Like they're going way too fast. And like, I felt bad just asking them more and more questions. So I was like, nope, they're going too fast for me. Then there was the opposite where I felt like I was too fast for my study group. And it was good because I was helping them and it was like forcing me to explain the concepts, but I wasn't getting any work done. Like I still have assignments I had to turn in. So I felt like it was making me as productive. So it does take a balance of like finding someone that is close to kind of like your style. When you guys transfer, hopefully you remember my words. It's going to be very scary to just ask a classmate to study, but just do it. Like like, hey, do you want to study? And just see what happens. Okay, because most of the time they were like, sure, yeah, I would love to study, because they were too afraid to ask that question, and we know we need it. Okay. So it does force you to step outside your comfort zone a little bit. When you go to the university, when you guys transfer, or maybe even here at DVC, it's huge. So you feel tiny. Okay, you feel tiny. And especially as a transfer student, you guys have 2 years, two or 3 years there. So it goes by really fast. Okay. And so with a study group, like for a lot of people, that's like some of their best experiences that they had at the university, because it was when you're shit talking the professor, you're shit talking the exams coming up, like you're just having a lot of bonding moments about your struggles, and it helps you see that you're not alone in your struggles. Okay. Exactly. So you see that other folks are struggling with the same thing, and it helps you not feel so isolated. Let's see, and then the last one, which I'm sure most of you guys are aware, is a lot of the online resources. I wanted to mention this part. I know that some of this has been very helpful to folks. You can find videos in a particular language. Sometimes there's cultural references that help you understand the concepts a little bit better. You can access them anywhere. If you're someone that does their homework at night, when the Math and Engineering Student Center is closed, what's the alternative if you need help? What's the tutoring service we have that's open all night? NetTutor. The NetTutor is available from 5 p.m. to 10 a.m. the next day. Okay, so they have tutors working that whole time, and it's a free service for you guys. And it's NetTutor. It's located right here. This button right there. You see right here, NetTutor. They have live math tutoring sessions, or what they call drop-off questions. So that one's 24 hours. So like if I'm stuck in a problem, I can drop off a question. So a tutor will provide some feedback, and then they'll respond with their feedback. Okay? If you do a live tutoring session from 5 p.m. to 10, it starts off kind of like very technical because it's on the chat room, but then you can request a video or audio tutoring session if you'd like that. Okay, you don't have to turn on the camera, but you can request that they turn it on, maybe to show you the problem or something like that. Okay. Where to go? So that's NetTutor, yeah, NetTutor. And it's also open all day, Saturday and Sunday, 24 hours. Okay, and so a lot of the things I mentioned, these 4 things I mentioned, one of the reasons we created these student centers is because it literally has all those in one spot that you can access all that, okay? And so that's why I hold my office hours there. There's workshops, study groups, boards everywhere. Cool. So for your participation, what I would like you guys to do is just do a little quick reflection. I'm a teacher. Just gotta get it. Also participation point. If you didn't do it well. Trevor, pass it out, please. Okay. So where to go? Make sure you put your name and date. Remember to put your last initial, please. First name and your last initial. And here's the reflection prompt. So from before out of class resources mentioned here, those 4 there. Mention which one do you plan to utilize more to help you prepare for the upcoming exam? And then why that one? I'm gonna stop the recording.